Okay, in this video we're going to look at confidence interval for higher level. I suppose the first thing I'm going to look at is margin of error. Okay, now, the margin of error is how much we could be wrong, and that's given as 1 over square root of n, and n is n being the sample size. That generally is not used in higher level, it's generally used in ordinary level. Okay, but I begin this video by just explaining how we would use it, how we would use this, okay, to get our confidence interval. What we'll actually be using though is the standard error of proportion. Okay, the best thing I could do is to explain it is to show or to answer this question using the margin of error. Alright, and then we'll go and we'll use the standard error of proportion then in progressing our question a bit. Right, so if we look at this question, it says a principal wants to find out how many students live within 2.5 kilometers of the school. He chooses a random sample of 60 students to survey. 20% of them live within 2.5 kilometers. Right, so let's just look at this. 20% of them, he's after surveying 60 students, and 20% of them live within 2.5 kilometers. But remember, he's only after surveying 60 kids. So like, his sample might not be the real case for the overall school population. I mean, he's only after choosing a sample of 60, so he's going to be a little bit wrong, or he might be a little bit wrong. So to see how much wrong he might be, we first of all get the margin of error. And remember, the margin of error is 1 over root n, and n, it says up here, is the sample size. So that's 1 over root 60, which will give us 0.129, which is, will be rounded to 0.13, and that is 13%. So according to this margin of error, he might be wrong by 13%. So here's how I set up my my confidence interval. That's 20%, but he could be wrong by 13, so I take 13 away and I get 3%, and I add on 13 and I get 33%. So even though he's after seeing that it's 20% from his sample, he could be wrong by 13%. So the confidence interval means I am confident, and I'll get to it in a second, 95% confident, that the actual real value of the overall school population is that between 3% and 33% live within 2.5 kilometers from the school. Okay, so that's really what we do. We look at his sample, then we find the margin of error, we take it away, we add it to it, and then we're 95% confident that in actual fact the real figure, or the real percentage of kids that live within 2.5 kilometers of school is between 3 and 33%. Alright, now where does this 95% confidence interval come from? Well, that really means we're 95% sure that the real figures lie between the 3% and the 33%. Okay, so that's how you do it in ordinary level. In higher level, to be honest, it's not much harder really. Instead of using margin of error though, because while it's accurate enough, it's not overly accurate. So instead of using margin of error, we would be using standard error of proportion. Now, I'm not going to get into it in too much detail in this lesson, but I suppose the standard error of proportion is just another way, I suppose, or a better way of looking at the margin of error. At least that's what we'll leave it at today. Okay, so now instead of using margin of error, we're going to use standard error of proportion. Now let's just look at it. Here's our formula. It's 1.96. That's actually 1.96, that's standard deviation there. Okay, so 1.96 standard deviations multiplied by the square root of p multiplied by 1 minus p over n. N here again stands for our sample size, and p stands for our population proportion. And what that means is the true value of how many kids live within 2.5. In the case of this question, the true value of how many kids lie within 2.5 kilometres of the school. Now, very often we're not going to know this actual or true population proportion. So what we very often have to do is, instead of using the actual population proportion, so again the actual amount of kids who live within 2.5 kilometres of the school, we have to use p hat. Okay, it's just a little kind of, I suppose, a hat over the b. And what that is the sample proportion. And the sample proportion is basically this, in this case, the 20%. Okay, so the sample of kids he has taken, the principal has taken, 20% of them say they live within 2.5 kilometres. So we don't have the actual proportion, so we must use the sample proportion. Okay. And it works the exact same as the previous one I showed you with the margin of error, except this time we'll be adding this to the 20% and taking that away from the 20%. Right, so here's how I'll set it up. I'll go 20% plus the 1.96 root p hat 1 minus p hat over n, and we will have the 20% minus the 1.96 root p hat 1 minus p hat, it's a bit messy now, sorry, 1 minus p hat over n, and that will be the true population. Okay, so the true population will be slightly greater than that and less than that. Alright, so I didn't give myself much space there, but hopefully that makes sense. Okay, so I'm just going to rewrite this a bit neater, and I'll change decimals to fractions. So we have 20%, which is 0.20 minus the 196 root, the p hat is 0.2, then 1 minus p hat, which will be 0.2 again. That's all over n, which is 60. Okay, and then I have my real population, and my 20% will go to 0.20 plus 1.96 square root of 0.20 1 minus 0.20, and that's all over again the 60. And just to neaten that up, I will go 0.20 minus 1.96 root, well, we have in here 1 minus 0.2, so that will end up giving us 0.2 multiplied by 0.8 all over 60. Plus 1.96, and the same over this side, 0.2 multiplied by 0.8 all over 60, and the square root sign goes over it all. Right. So lastly then, if we just work this out, we'll have 0.20 minus 0.1012, and the real proportion, the real population will be bigger than that, but it'll be less than this, and again it'll be 0.1012. So the real population will lie between 0.098 and 0.3012. Okay, so we could leave it like that, but I personally prefer percentages. So as a percentage, it'll be 9.88% and 30.12%. So the real amount, or actually going back, we are 95% confident that the real population based on our sample is between 9.88% and 30.12%. So between those two, I'm 95% confident that between this number of people, percentage of people, are within 2.5 kilometers of the school. Okay. Thanks for that, guys. Hope it helped.